Hello everyone, my name is Sonali and I'm a sustainability consultant based out of Delhi, India. I'm a lead AP in building design and construction, and today in this video we will be discussing the materials and resources category under LEED B4. So this video is part of our social initiative where we aim to train people who want to give the LEED GA exam and make a difference. So before we begin, I just wanted to highlight that a lot of you who are watching our video have not subscribed to the channel. So it'll be good if you can do that because that will help us get motivated and make such more videos for you. So with that, let's begin. So in this category, for the introduction part, I've just listed the key terms that you can look into in terms of the LEED GA exam. So these key terms are important to understand and also important to remember when you will be giving the LEED GA exam. So in this category, we have two prerequisites and 5 credits. So the two prerequisites that you see are related to the waste management, and the 4 credits are related to the product or materials, and one other credit is also related to the waste management strategy. So the total points here are 13, and we'll be discussing each one of them with the intent and strategies that we go into. So just as a starting point, let's learn what life cycle assessment is because that forms a major part of this category. So there is a credit in the category which is building life cycle impact reduction, which has 5 points. So this one mainly focuses on the life cycle analysis or the assessment that you do in terms of choosing the material and also performing a whole building life cycle so that we can analyze the materials that we're using and propose alternatives accordingly. So life cycle assessment is basically of two types in this case. In this credit, one is a whole building. This will include the environmental impacts associated with the materials and the systems that make up the whole building over its entire life cycle. So this necessarily does not talk about a particular material or product, but this is talking about all the materials and products that make up a building, and that's where you perform the analysis to arrive at a result where your building is standing in terms of its whole life cycle. And for products and materials, this is basically a compilation and evaluation that determines that the total environmental impact from a particular product or material. So this life cycle is actually the basis of EPD, which we'll learn in the next slides. So this is mainly product specific or material specific, and this helps you build a whole cycle LCA. So it's basically if a product has an LCA, then you know its environmental impacts. Only then you can calculate the whole building. So this is basically part of the whole building LCA. So there are different softwares available in the market by which you can perform the life cycle assessments of the material. And this is like OneClick, SEMA Pro, OpenLCA, EcoChain. So I think OneClick is something that I've used personally, and it is a fairly easy software and compared to others because it is less complex when you're inputting your quantities and inputting your materials for the region. And yeah, so you can try out any of these to understand how to do that. So let's move to the second thing, which is EPD, Environmental Product Declaration. So this is basically a standardized, internationally recognized, comprehensive tool for providing information on products or any materials based on their environmental impacts. So this is based on an ISO compliance. So an EPD is based on an LCA. So, and then it is again verified by third parties. That's where you arrive to these product declaration. So this is actually verified by third party as per ISO 14025, and this is done for a type 3 EPD. So type 3 EPD is the EPD which has been verified by by a third party. So for example, let's say we drink milk or we have packaged products, and we often go to the market and we see that there are labels there which mention what is the quantity. Basically, it discloses the content of its products. So similarly, an EPD discloses a product, a building product's environmental impacts. So this is similar, and this is done based on the six impact categories that we'll be discussing later. So this is basically a general analogy that I like to tell people when I'm trying to explain EPD, because it's easy to understand what an EPD does basically. And now we have PCR. So PCR is a set of specific rules. So when you have to establish an EPD, you need uh, a set of rules in the market, because anybody cannot establish their own EPD as per their own choice. So there are some rules which are provided by the industry, or which are specific to a product. And let's say you have to go and develop an EPD, you have to look at those rules, PCR, which are a specific set of rules, requirements, and guidelines based on the ISO specifications for developing environmental declarations. So first you look at the PCR for your particular product, you read the rules, and then based on that you do an LCA of your product. And once you've done the LCA, then you apply for an EPD, or apply for prepare an EPD, and then you go for a third party verification. So that's a full cycle of how an EPD is formed, or how an EPD is established. Similarly, we have HPD. This one stands for Health Product Declaration. So this is a tool that reports the product contents and its relationship of each of the ingredients in the product to human and ecological health. So this one is more relevant to not to the environmental health, but to the occupant or the human health. So this talks about the impacts that the product might have. For example, if a product has VOC content, so what would be the limit of VOC content that is good for human consumption, or acceptable? So that's where HPDs come into picture, where they tell a picture of what is the human impact of the particular material. So now I think we can move to the intent of these terminologies that we just discussed. So the intent here is that we encourage the use of products and materials for which life cycle information is available. So the intent of having an EPD is not that the product is performing well, or the product is reducing its impact, but its intent is to have the life cycle information available, because only when we have the information available with us we can make an informed decision. So it's important that a company or a manufacturer discloses the environmental impact of a product, so that the occupant or the contractor, they are aware of the environmental impacts. And other intents of this particular category is that they should prefer material with a lower environmental impact. That's the second step. And the third step would be to have like a lower embodied energy material, which consumes less energy in terms of its extraction, manufacturing, and transportation. So there are three main intents here. First is we talk about material conservation. Second, we talk about strategies and intent for environmentally preferable material. There are different definitions of environmentally preferable material, because there are certain standards that you have to follow if you want to claim, if you want to use a particular environment friendly product. And third is waste management. So as you can see, the first and second, these talk about materials, and the third one talks about the waste management. So first we'll be looking at the intent and strategies for material conservation. So the intent here is that we reduce the amount of raw material that are used. So before you even select materials for your building, the intent here is to reduce the amount of materials that you are using now. So yeah, so it's important that we reduce the amount of raw materials that are extracted, and we reduce the amount of materials that are used in the operations. So which would mean that we use materials that are long lasting, or we reuse materials from a different site, from an existing building, or from an abandoned building. So this intent actually resonates to the credit building life cycle impact reduction. So this is a very important credit in this category, and it has multiple options to go about it. So you can reuse buildings and materials. So you can reuse a historic building, because if you build a new building, it will have more of the environmental impact. It will have more of the embodied carbon, more operational carbon. So if you're using an existing building, you are reducing or negating the embodied carbon of the material, because the materials have already been there. So that's a good approach when we are doing material conservation. Second would be to renovate an abandoned building. If there's an abandoned building and the spaces are adaptable, then you can renovate a building and use it for a different purpose than the one that was intended it for. And the third would be salvaging building material from scrap building. So there are a lot of scrap buildings, the material is lying and we can use that for a different building. So the scrap building material, if you're using it in a new building, then of course you're reducing the embodied carbon, because it was already used in a building before and now you're reusing it. So that's another approach of material conservation. And of course, the second step here for material conservation is to perform a whole building LCA. So if you perform a whole building life cycle assessment, then you are able to calculate that this is my material and this is the amount of years. This is the entire life cycle of my building, and this would be the carbon emissions of my building in terms of embodied carbon. And if we can propose certain elements instead of, we can see how much is the highest performing materials, which of the materials are the highest energy intensive or high carbon intensive, then we can propose alternatives by performing a whole LCA. So that's where this becomes important in terms of material conservation. So these two, I think these strategies are important when we are talking about material conservation. And this we briefly discussed: reusing historic building, renovating abandoned building, salvaging building material from scrap, and performing a building life cycle life cycle analysis. Yeah, so before we move to the part where we will talk about the environment friendly materials or environmentally preferred materials, let's have some questions. So the first question is, what is the intent of material conservation? Option A, diverting waste going into landfill. Option B, reduce the environmental impacts associated with waste generation. Option C, promote sustainable building materials. Option D, reduce the raw materials going into construction and operational of the building. And option E, use more of recycled material in construction. So you can pause and read through if and let me know your answer. I'll just move to the answer now. So option D is the correct one, which says reduce the raw materials going into construction and operation of the building. So this is important because we are just reducing the need for new materials. So that is the major intent of the material conservation practice. So now we'll be moving to the intent and strategies for environmentally preferred materials, because we've discussed how we can conserve material, reduce the need of new materials. Now we'll be discussing which are the environmentally preferred materials, or what is the criteria of choosing the environmentally preferred material. So in this category, we have these credits which talk about building product disclosures and optimization. So we have different categories there: building product disclosures and optimizations. Under that we have EPDs, then we have sourcing of raw materials, and then materials ingredients. So each of the credit has two points, and in this video we'll only be covering the EPD section, and we'll talk about the rest of the environment friendly materials in part 2 of this video. So when we talk about environmentally preferred material, what is it that we should be considering? Because it could be environmentally preferred for a different number of reasons. So the first thing is what we should consider is raw material acquisition. What is the raw material that goes into the material? Is that material renewable? Is that material environment friendly? And then the manufacturing process. Is the process something that takes a lot of energy, or is the process very energy intensive? So that's something we should be looking at. Third is packaging. The packaging of the material, is it sustainable? Are we having plastic as a, for example, plastic as a packaging material. So that's a very minute but an important aspect of a material. And then you have distribution location. So how far along is the material going? What is the manufacturing process, manufacturing factory, and then the distribution factory? So what is the distance that the product is traveling? So if the product is local within the region, then the emissions from the transportation are reduced. So that is where the distribution location is important. And then fifth is reuse and recycle post use. So what is the scenario, the end of use scenario for that product? For example, if a product has been designed to be in a building, and then after it is demolished, the product is of no use, we cannot recycle it because of the composition that it has, we cannot recycle it or reuse it. So that would be the end of life scenario. That's important to look into a material's life cycle. And the last section is disposal. How is it being disposed? Is it being disposed in the landfill, or is it being diverted through other means, or is it ecological friendly after the disposal? So that's the last part of the considerations that you should be taking when we are selecting a material. So yeah. So the intent here, now that we have listed down the considerations, the intent here is that the project team explores environmentally preferable materials and products that have sustainable characteristics. So the sustainable characteristics, we'll get into that now. So what are those characteristics? What are the characteristics that make up a sustainable material? So the first would be that it has a reduced energy use from transportation. So if a product is local, then the transportation emissions will be less because it will have to travel less to reach the site. Yeah, so the second is sustainably grown and harvested. So this talks about forests, sustainable forests, which are grown in a way that does not harm the soil health a lot. So that would be one of the aspect of when we talk about sustainably grown and harvested. And the second would be intended end of life uses, as we just discussed. So there is a plan of end of life of that material. So that's how you know that the product is an environmentally preferable material, and it has a recycled content. So even when the product is it's a new product that you're using, even then it has recycled content. So that's a scenario. For example, in concrete, there are possible recycled content of fly ash or GGBS. So those materials are basically a byproduct from a different industry that would have been otherwise gone into the environment. So we are including it in the concrete mixture and basically reducing the concrete amount that otherwise would have gone into the concrete block or a concrete slab. So that's where we are negating the impact of the original material by inputting recycled content in that material. Next would be bio-based materials. So these will be materials that come from natural substances, like for example, you have a jute bag. Yeah, so the characteristics would be to know the ingredients of the material. For example, we discussed concrete, so it's important if we know the ingredients, because then we can make a choice of choosing a material with less harmful ingredients. And then we have long lasting, durable, and reusable. So any material which is long lasting or has a longer shelf life, and because it's durable, it's important because those materials will actually increase the life cycle of the material of the building itself, so that you don't, without being the need of replacing them very often. So you're not introducing a new material whenever you're replacing it, because the product is more durable, so you are able to increase the shelf life of the material. And of course, if it's reusable, then it also reduces the recycling process and all that. So it's directly reusable. It's the best characteristic for a material. And of course, it's produced in a socially responsible factory. So the workers that are producing the material, they have good working conditions. That would be a criteria again for environmentally preferred material. And so moving into the credits for materials and resources, we have the first one, which is building product disclosures and optimizations. This talks about environmental product declarations, EPDs, which has 2 points. So the requirement of this credit is simply to use EPDs. So basically use products that have EPDs or have product declarations. So even product declarations are of different kinds. EPD is one of them. So if you look at the option 1 of this credit, it has two options. The first one tells you to simply use 20 building products and materials from at least 5 manufacturers that meet one of the disclosure criteria. So the first criteria is product specific declaration. Either it has that or it has industry wide EPD, product specific EPDs, or any other USGBC future program that is approved by USGBC. So simply the calculation here is done based on the number of materials or products that the project is using. If it can make up to 20 products, then it is compliant. So the calculation here is based on valuation. So if let's say a product has product specific declaration, this is a publicly available data of LCA. This is reviewed by peer, but it is not actually third party verified. So this is given a weightage of 0.25 of its original value. So if it's one product, it will be 1 into 0.25. 0.25 would be the value of that product. Similarly, industry-wide EPD. This is an EPD that is generic to the industry. So if it's a product is there in the industry, so the data will be based on an industry average. So whatever is the environmental impact of the material in the region or in the industry, this EPD will specify an average value of that. So this is not necessarily like product specific from a manufacturer. So again, this is also verified. So this has been given a valuation of 0.5. And when we come to type 3 EPDs, product specific, these are the EPDs that are given from the manufacturer for particular product. So this is not generic. This is very specific to that particular product of that particular manufacturer. So this is given a weightage of 1. So one product will be 1 into 1 only in this valuation calculation. So let's look at an example. So for just to understand, I mean, you will not get this as a calculation in the exam, but this is just to understand the evaluation, that if you have two products with the product specific declaration, if you have three products with industry wide EPDs and one product with product specific EPDs. So this is a project, like this is a sample. So you will have this as a valuation, right? So this will be the actual values of the product. Even if the number is different, you see the values coming after the valuation is different. So if you add that, you will get three environmentally preferred products. So we are getting at least three products currently. So this would be the way you will the valuation works. Now the option 2 in this credit, this talks about using products that comply with any of the criteria. So this option 1 was based on the number of products, but option 2 is based on the cost of the product, percentage of cost, right? So the criteria here is that it has, so this option also goes beyond EPD. So EPD is just declaring that this is my ingredient, this is my environmental impact. But in option 2, they are asking for products that actually are reducing their impact. So, or they have a plan of reducing impact. So that's a different, that's an enhanced approach or a forward approach. So in this one, what we do is we have three categories. One is either the product has third party certified products that demonstrate reduction. Second is product sourced within 100 miles of the project site. So if a product is sourced within 100 miles of the project site, then it gets a different valuation. And again, USGBC approved programs. So like I said, in this one, we are calculating the percentage of cost. In the previous one, we were looking at the number of materials. So for a verified product, third party verified, which is actually demonstrating reduction, it gets a valuation of 100%. So what is the reduction where is the reduction that we are asking for? So this reduction is on the impact categories. So this we discussed earlier as well in the video. So we have 6 impact categories that LEED focuses on. So these 6 are basically environmental impact. This is a measure of environmental impact. So let's say global warming potential. So this is in kg CO2. So in global warming potential, this is actually the carbon emissions that a product is emitting in throughout its life cycle. So that GWP is the amount of kg CO2 the product is emitting. So that's one of the indicators. So similarly, we have 6 indicators, and the product should demonstrate at least reduction in 3 categories to get basically to comply with this. So that product will get 100% of its valuation. Okay. And the second one is the products that are local, that are sourced within 100 miles, those will get 200% valuation. So you see the focus is very clear here that a product that is regional or local to the project site, that has a higher valuation because you are reducing on the transportation emissions there. So yeah, so again, let's look at it from an example. Again, this will not come in the exam as a calculation, but just to understand the evaluation. So you have, let's say, $300 worth of products with reduction in impact categories, and $200 worth of products sourced within 100 miles of the site. And again, the rest of the products, like $400 worth of products, they're not meeting the criteria. They are the rest of the products of the building. So in this case, you will just calculate the valuation of the products which has the declaration, which has the criteria, which meets the criteria, that is having impact, having reduction in impact categories, and again the products being within 100 miles of the project site. So based on that, I get a number of $500. That would be my that would be my cost for the optimized material, and then I will calculate it from the total amount. So I am getting 55%. So 55% of my materials are meeting the criteria. So 55%, this is by cost. So this is not done by quantity or the number of materials like in the other option. So again, this is the compliant scenario. So in this credit, we learned about two options. First was the option where we discussed selecting EPDs, like 20 EPDs from 5 different manufacturers, which meet the disclosure criteria. And in the second option, we talked about the percentage of cost. So percentage of cost or percentage of materials by cost, which meets the criteria of further reducing the impact, right? Apart from having EPD. So that's the second option. A project can go for both the options or either of them. So it's optional for the projects. And yeah, so this is the end of this video, and I will have some questions now. So the first question is, which of the following does not exemplify strategies of reducing harm to the environment over a building's entire life? A. Restoring a historic building. B. Using salvaged flooring in a new building. C. Conducting a life cycle assessment to help reduce a building's environmental impact. Or D. Tearing down a building and putting up a more energy efficient one in its place. So you can pause and reflect what you think is the right answer. We'll move to the answer now. So the answer is D, tearing down a building and putting up a more energy efficient one in its place. So like there's a saying that the most sustainable building is the one that is not built, because you are, instead of reusing a building that can be used, that can have adaptable spaces, you are putting a new one, taking up all the resources of the environment. So that's where uh, this is something that does not exemplify strategies of reducing harm. So the second question here is, which type of the below product declaration is provided by the manufacturer for a specific product and is reviewed and verified by a third party entity? Product specific EPD type 3, industry wide average EPD or generic EPDs, product specific declarations, or D, none of the above. So the answer for this one is product specific EPDs type 3. We discussed this before. This is a type of EPD which is product specific and manufacturer specific, and then again it is verified by third party. So this is the correct answer. So with that, thank you so much for watching the whole video, and we'll see you in the part 2 of this video where we discuss more environmentally preferred materials for other credits and also the waste management strategies. Thank you.